I was asked to do a little explanation of the mole roadmap and also to talk y'all through number 9. So I'm going to do both of those things now. Sorry it took me a while to get the video up. I have been doing video conferencing basically the whole day. And so I haven't really had a solid chance to work on this for you. Anyway, so the mole roadmap is designed to remind us that if we're trying to get from, for example, mass to a particle, so our particles could be like atoms or molecules, we have to go through moles. So we have to go through moles and then over to particles. We can't just jump straight into the number of particles. That's not how it works. And the same thing with the gas volume. You have to go through moles if you want to turn the gas volume into the mass, or if you want to know how many particles are in the sample of gas. Okay, so I have an example here that I'm going to work through, and I'm going to kind of reference our mole roadmap along the way. So this is problem 9. It's talking about chalk, which is calcium carbonate. So I'm just going to go ahead and write that formula out. CaCO3, calcium has a 2+ charge, carbonate has a 2- charge. And so because of that, we only need one of each of those, and it's balanced out. If a piece of chalk weighing 3.784 grams weighs 3.597 grams after I use it to write my name on the chalkboard, how many atoms of each element did I leave on the chalkboard? So ultimately, if I'm looking at this, what I'm being asked to do is I'm going to be starting in grams, and I'm being asked to go to moles so that I can go to number of particles. And in this case, the number of particles that I'm looking for is the number of atoms. Okay, so this shows me that my first step is going to be to turn the mass in grams into moles. So I'll start with that. Since we wrote on the chalkboard, the difference in the mass of the piece of chalk is presumably what's left on the whiteboard, or the chalkboard rather, so we can do the starting mass of the chalk, 3.784 grams, minus the mass of the chalk after we wrote with it, 3.597 grams, and that gives us 0 point something. Let's see if I can get this to work. So silly pepper. 7. Oh my God. Wait. I just have to double tap it. All right, guys, now I'm cooking with fire. Check it out. Okay, 0.187 grams of calcium carbonate was left on the board. So that's going to be my starting mass. So like a assembly table. I just kicked her. Anyway, 0.187 grams of calcium carbonate. So the next thing I need is, of course, the molar mass of calcium carbonate. So I'm going to look at my best friend, the periodic table, and I'm going to go ahead and try to calculate that molar mass. So mass of calcium is about 40, and then carbon is about 12, and oxygen is 16 times 3 is 48. So the mass is just about 100 on the nose. So 100 grams of calcium carbonate in 1 mole of calcium carbonate. And so this is cool because now we're in moles, which our mole roadmap told us that the first step to getting to the atoms was going to be to go to moles. Now, since it's asking me atoms of each element, I'm going to need to do a calculation for calcium, carbon, and oxygen. So I'll go ahead and just start this calculation as calcium. And so in 1 mole of calcium carbonate, there is 1 mole of calcium because there's 1 calcium in calcium carbonate. Now that I am dealing in calcium, which is a single atom, I can use Avogadro's number to say 1 mole of calcium is 6.022 times 10 to the 23rd atoms of calcium, right? And so then we can do the math for that guy. So we have that difference that we found for the mass of the chalk times 1 times Avogadro's number. Whenever you're putting in Avogadro's number, I really encourage you guys to think about putting it in parentheses so that the order of oh my God, I can't even talk. The order of operations doesn't get messed up. Sometimes your calculator decides to go rogue and do things in a weird order, and then you'll be sad because your answer is wrong, and you'll be like, but why? So just give it a little parentheses hug and you'll be good. Okay, so this should give us about 1.26 times 10 to the 23rd calcium atoms. And just a little side note, this E, oh gosh, this little double E on the calculator, so it's double E right here, and it's just a single E when it shows up on the screen. That is just a symbol that means times 10. If you typed in 6.02 times 10, whoops, go back, times 10, and then raised it to the 23rd, that would be totally fine too, okay? They're the same thing. See, it spits it out, it's the same. Okay, anyway, I digress. So there is calcium, and you might be saying to yourself, the step where we switched from calcium carbonate to calcium was 1/1, like the numbers were 1/1. It didn't really do anything to change the answer. And you're not wrong. However, it's still appropriate to consider the number of each element in the compound because we'll go ahead and do oxygen next. If we look at the setup for oxygen, it's going to be basically the same. We're starting, oh my goodness, in the same spot, so 0.187 grams calcium carbonate. We still need to go grams to moles, so we have 100 grams as the molar mass of calcium carbonate. We have 1 mole of calcium carbonate. And then we're back to this mole to mole ratio where we're showing how many of that particular atom are in the compound. And in this case, for oxygen, there's actually 3 moles of oxygen for every 1 mole of calcium carbonate. And so that crucial step right here and right here of switching from the compound to the atom is going to affect your answer. So don't just write that step off. It's really important. So 1 mole of oxygen is Avogadro's, oh, hello, go away. Avogadro's number of atoms. And you can go ahead and work out that math. It's going to be about 3 times your answer for your other problem. And so hopefully that clears up some of the confusion around this problem. The answer for carbon is actually going to be the same as calcium because it also has that 1-to-1 mole ratio in the middle. But it starts the same and ends the same as the other two. And so, yeah, hopefully that clarifies this problem a little bit and clarifies how we use the roadmap. The roadmap is just telling us where we started, and then it's telling us what we should use to get to moles so we can change to whatever we want, right? So it's showing us, okay, if you're going from mass to moles, your molar mass should be on the bottom and your moles should be on top. And that holds true, right? We're changing from mass to moles. And so we had our molar mass number on the bottom and our moles on the top. Okay, so that's the purpose of this map. It works really well for some people. It helps them visualize what they're doing. If you're like, I don't need this map, it is confusing to me, then don't use it, right? As usual, everything